functions. Boom, functions. I'm going to start in functions. What are functions? So if you search it up for functions, its definition is right here. A relational expression involving one or more variables. So most teachers, most math teachers, they teach you that functions as a mapping thing. So, you know, this. There are several types of functions. So here's what a function looks like. So we have x, which is your input, and f of x is your output. So there's that. So the first function we're going to meet is like a one-to-one. It's going to be a one-to-one function. 1-to-1. So one-to-one functions means that like it means a function that when you input one value in, it'll give off and the result will be one unique value. So let's say example, the linear function basically like 2x. So here if we input 1, 2, 3, 4, change the brushes first. Then we will have 1, 3, 5, 7. Right here. You can see it's like a mapping device. So here functions x is 2, so it's -1. The other type of function is many-to-one. So let's continue. So many-to-one. Many-to-one. Hold up, this is looking kind of strange. There you go, many-to-one. This looks more fancy, doesn't it? So many-to-one functions. This. So let's say 1 and 2, and these 2, 3, 3, 3, 5. I'm just setting an example here. So like this. You input 3 and 5. Both of these values will be equal to 6. And then 7 or 0. They're both of the results. If you input them, both the results are going to be 0. So this is many to 1. But like when you input two or more values in, they actually equals to one result. So many to 1. So many to 1 functions, they're like quadratic functions. Quadratic functions are many to 1 because like you input, and when you solve an equation, you always have like 2 answers. So that's many to 1. Also, cubic functions also is a many to 1. So 3 values will be equal to 1 value, like that. So these two ones are the main ones you'll have to encounter. It's just like, and this is just an explanation for what functions are. So how do I identify a function? How to identify. That's why you use text instead. How about say how to know if it's a function? So to see like if something is a function, we need to do what is called a straight line test. Hold up. Ah! Just encountered a little trouble. Yeah. Right here. Where were we? Ah, yes. So, how to identify a function? Use what is called a straight line graph. Not straight line graph, straight line test. So first of all, let's say we have this graph here. I'm just going to draw any functions like a cubic curve or whatever. So here, how do we know it's a function? What we have to do is to draw a straight line over it. It's like a vertical line. It's not a straight line test as well. Vertical line test. Vertical line test. So you draw any vertical line on the graph and it only passes one point, only touches one point of the graph, then it's a function. So as you can see, it touches this point only. It's only 1 point, only one. Then this is a function. Let's say function. Function intersects 1 point of the straight line. So How about another one? Let's say this graph. So now then, to see if it's a function, we're just going to apply the straight line graph right here. And oh no, it actually touches 2 points. Because if it's a function, it only can touch 1 point, then this one is not a function because it touches more than 1 point. If it touches 1 point, then it's a function. If it touches more than 1 point, then, well, it's not a function. It's not a function. All right, understand. So for the vertical line test, if it's a function, you draw a straight line at any given point, and the straight line only crosses 1 point. But if it touches more than 2 points, then it's not a function. And when it touches 1 point, then it's a function. Just like that. Doesn't matter what shape the graph is. If the straight line just touches 1 point, then it's a function. That's it. That's the straight line test. All right, let's move on to domain and range. We're almost there for today's session. So, domain and range. Let's see. Hold on, let me test something first for the Twitch.
It was sometimes him finding an opening alone and then just continuing on with it and doing such a good job of chaining the kills together. Right, let's move on. So, what is domain and range of a function? So, domain and range. So, domain and range are like what the values of for x and y does the function has. So it talks about like what sets does it allow, does it work for the function, and what does it not. So let's talk about, let's solve a quadratic equation. So quadratic equation comes with this curve is a parabola, like we talked about right here. So here's the vertex. So it's like it's the maximum point for the y value, and we can say that for the domain of this graph is equal to
x equals to a real number. Because like at any different point, it's actually going to be any value fits for this one. It's like any given value, there's no like, max x, or like once it gets to a point, x doesn't work on the graph. It works for everyone. However, for the range, alright, just beware, domain is for x, range is for y. So, range. We'll see here. Let's say the vertex is like -3. So say that like, because like beyond -3, there's no line, there's no points, there's no graph. You cannot exceed from -3. So we say -3 is not lesser, bigger. Y is bigger than -3, and then y is also equal to the real number. That's how you identify the domain and range. You see a graph, and then you see like, oh, which point is that? What's the max limit for x? What's the limit for y? And so like within those range of values for x and y, then this function can work. Does this function prohibit and contain? So onto a more easier one. So let's say here. So see this function here. Let's say it ends with -6 and x is 3. And so on. It's just like that. It's like identify the range, the domain and range for the function. It's like find out like what set of values does this contain. Does the function contain? So just set up limits like y is bigger to -3. So no. And for this one, you just identify like what's the max, what's the min, and then like what x and y contains within. So it's like that. We'll elaborate on next session, and that's it for today. So thank you all for joining the stream. Goodbye.